Imagine an AI that's faster, smarter, and cheaper to run. Last week, we followed DeepSeek's Open Source Week event, and let me tell you, they were dropping some seriously impressive open source projects every single day. I scrolled through some X posts about it, but here's the thing. A lot of the posts about it are filled with numbers and deep tech jargon, making it hard to see the big picture unless you're an AI researcher. So, I made a little video to unpack it all for you. I'm breaking down each of DeepSeek's announcements in a way that's easy to digest. No confusing jargon, just straightforward, simple explanations. I want you to see why these updates are actually worth caring about, like a friend chatting with you over coffee. Welcome back to AI Handbook, your go-to source for the latest AI breakthroughs. To stay ahead of the curve, make sure to subscribe and turn on notifications so you don't miss out. So, let's kick things off with Day 0. This was DeepSeek just getting warmed up like a little teaser before the main event. Think of it as them rolling out the red carpet, setting the stage for the really big releases to come.
We're a tiny team DeepSeek AI exploring AGI. Starting next week, we'll be open sourcing 5 repos, sharing our small but sincere progress with full transparency.
DeepSeek's vibe is super refreshing, isn't it? They're keeping it real with that humble tone. I mean, words like tiny team and small but sincere progress make them feel approachable, like they're just a group of curious folks tinkering in a garage. It's a nice change from the usual tech bravado we sometimes see. But at that opening line, they're not that much shy about their big dream, chasing artificial general intelligence. It's like they're throwing down the gauntlet, saying, hey, we're in this to win it. It sure looks like they're gunning to be the frontrunners in the AGI race, and I'm here for it. Then there's that promise of 5 open-source repositories, all built with full transparency. That's a bold move. It's like they're inviting us all backstage to see how the magic happens. They're setting the stage for something big, and it's got me curious. Sounds like they're ready to share some seriously cool stuff with the world. All right, let's keep going.
These humble building blocks in our online service have been documented, deployed, and battle-tested in production. As part of the open source community, we believe that every line shared becomes collective momentum that accelerates the journey.
Exactly. This sentence is like the heartbeat of DeepSeek's whole open source week vibe. They're not just tossing out some cool AI tools and calling it a day. They're playing a bigger game, trying to bring the whole AI community together like a giant brainstorm session. Instead of hiding away in some secret lab, they're betting that AGI, and maybe even ACI down the road, will show up faster if everyone's pitching in. It's like they're saying, hey, let's all share our toys and build something amazing together. That idea of collective momentum is so spot on. If they're right, this open source approach could turbocharge AI progress in ways we can't even imagine yet. Let's see what Day 1 offered. Day 1 was all about FlashMLA, and I'm pumped to break it down for you.
Honored to share FlashMLA, our efficient MLA decoding kernel for Hopper GPUs, optimized for variable length sequences and now in production.
So, FlashMLA stands for Matrix Language Algorithms, and it's built to work with NVIDIA's shiny new Hopper GPUs. Think of those as the latest, greatest engines for powering AI. In plain English, FlashMLA is like a turbocharger for AI models. It's designed to handle text or data that keeps changing lengths, like when you're chatting with a bot or translating a sentence that could be short or super long. It keeps everything running fast and smooth, no hiccups allowed.
BF16 support.
Now, let's talk about BF16, or Brain Floating Point 16. It's a clever way to do math in AI. Imagine you're baking cookies. You don't need to measure every sprinkle exactly, right? BF16 lets the AI crunch numbers quickly without wasting space, so it can process more stuff while still being efficient. Less memory, more speed, win-win.
Paged KV cache, block size 64.
Then there's the KV cache. This is the real hero. KV stands for key value, and it's like the R is short-term memory. Picture this, you're texting with a chatbot. Without a KV cache, every time you send a message, the AI would have to reread the whole conversation from the start. So slow. But with a KV cache, it's like, oh yeah, I remember what you just said, and bam, it replies in a flash. The paged part means it organizes that memory into neat little chunks, and the block size of 64. That's how much data it grabs at once, 64 units per go. It's like grabbing a handful of chips instead of picking them up one by one, way smarter and faster.
3,000 gigabytes per second memory bound and 580 teraflops compute bound on H800.
Alright, let's dig into these big numbers like we're unwrapping a fun puzzle together. Promise it'll be easy to follow. First up, 3,000 gigabytes per second. Picture this, GBs means gigabytes per second, so 3,000 gigabytes per second is like FlashMLA moving 3 terabytes of data every single second inside the GPU's memory. That's wild, right? Next, 580 TFLOPs. Okay, TFLOP sounds fancy. It's short for tera floating point operations per second, but it's just a way to measure how fast the GPU can do math. At 580 TFLOPs, the H800 GPU is blasting through 580 trillion calculations every second. Think of it like a super smart calculator on steroids, solving millions of tiny problems faster than you can blink. That's the muscle behind RE's heavy lifting. Alright, here's the bottom line, nice and simple. FlashMLA is like a speed demon for AI. It's all about cranking up efficiency, making the most of memory and raw computing power on those beefy H800 GPUs. The result? Lightning-fast AI processing with barely any lag and perfect for stuff like real-time chatbots or instant translations where you can't afford to wait around. It's a slick move by DeepSeek to kick things off. And that's just day one, can you believe it? They're already bringing the heat. Ready to see what's next? Let's keep rolling. Alright, day 2 star is DeepEP, and it's all about making AI teamwork a breeze with something called Expert Parallel, EP.
Excited to introduce DeepEP, the first open-source EP communication library for MO model training and inference.
EP is a clever way to train mixture of experts, MO-E models. Those are AI setups where you've got a bunch of expert mini-models, each great at its own thing. Imagine a team of specialists, one's a math whiz, another's a language guru, and so on. Instead of one person, or GPU, trying to handle every task solo, which takes forever, EP splits the work across multiple GPUs. Each expert gets their own piece to chew on, and they all work at the same time, in parallel. Boom, job done way faster.
Efficient and optimized all-to-all communication. Both intranode and internode support with NVLink and RDMA.
Here's the scoop, NVLink is like a high-speed express lane for GPUs hanging out in the same machine. It lets them swap info crazy fast. Think of it as a group of friends passing notes in class without the teacher slowing them down. No bottlenecks, just zippy communication so all those expert AI pieces can work together seamlessly. Then there's RDMA, or Remote Direct Memory Access. This one's the champ for when your GPUs are on different machines, like across a room or even a data center. RDMA lets them send data straight to each other without bugging the CPU to play middleman. It's like texting your buddy directly instead of asking someone else to relay the message, way quicker and less hassle. This cuts out the lag and makes massive AI training feel like a breeze. Together, NVLink and RDMA are like the dream team for DeepEP, keeping the chatter fast whether the GPUs are neighbors or miles apart. DeepSeek's basically handing out a turbo boost for big-scale AI projects, and it's all open source. Pretty awesome, huh?
High-throughput kernels for training and inference pre-filling.
High throughput means DeepEP can handle large amounts of data efficiently.
Low latency kernels for inference decoding.
Low latency ensures AI models generate responses quickly, making real-time applications, like chatbots, much more responsive.
Native FP8 dispatch support. Flexible GPU resource control for computation communication overlapping.
So, what's the big deal? Here's the scoop. Faster AI training. Models learn quicker because the GPUs are swapping info at lightning speed. That cuts down the time it takes to get them ready, like going from weeks to days. Sweet, right? Snappier AI responses. For real-time stuff like chatbots, this means they're on the ball, replying to you without that awkward pause. It's like they've had a shot of espresso. Saves cash and energy. By using tricks like FP8 and slick communication, NVLink, RDMA, it needs less computing muscle. That's less power, lower costs, and suddenly AI feels more doable for smaller teams, not just the big shots. Think of it like swapping out old, crackly walkie-talkies for superfast Wi-Fi. Everything just flows better. DeepSeek's basically saying, here's a tool to make AI quicker, cheaper, and sharper. Go have fun with it. And since it's open source, it's up for grabs. Love how it's coming together? Me too. Let's roll on to day 3 and see what DeepSeek's got cooking next.
Introducing DeepGEMM, an FP8 GEMM library that supports both dense and DeepGEMMs, powering V3/R1 training and inference.
So, DeepGEMM is all about supercharging matrix multiplication, the heavy lifting behind how AI models crunch numbers. It's a slick library built to handle FP8 general matrix multiplications, GEMMs, which is a fancy way of saying it does superfast math with 8-bit precision. Why's that cool? It means AI can process huge piles of data quicker, using less memory, and still keep things accurate enough to trust.
Up to 1350 plus FP8 teraflops on Hopper GPUs.
This thing's a beast. It's hitting over 1,350 trillion calculations per second using that 8-bit FP8 magic on NVIDIA's Hopper GPUs. That's like a math wizard solving problems faster than you can say wow.
No heavy dependency, as clean as a tutorial. Fully just-in-time compiled.
DeepGEMM doesn't mess around with pre-made plans, it builds its math tricks on the fly with just-in-time, JIT, compilation. Think of it like a chef whipping up a fresh dish right when you order, no stale leftovers here.
Core logic at 300 lines, yet outperforms expert-tuned kernels across most matrix sizes.
It's just 300 lines of code, super simple, but it beats out those fancy, hand-tuned setups pros spend ages perfecting. It's like a tiny car outracing a tricked-out supercar across all kinds of tracks.
Supports dense layout and 2MO layouts.
It's flexible, handling regular dense matrix setups plus 2 special layouts for mixture of experts, MOV models. That's like having a tool that works for both big group projects and small, specialized teams, super versatile. Alright, let's wrap up day 3 with a quick and juicy bottom line. DeepGEMM makes AI calculations faster, more efficient, and easier to use. It's like giving AI models a supercharged calculator that works at mind-blowing speeds while using less memory. DeepSeek's basically saying, here's a fast, efficient boost for your AI, enjoy. And that's day 3 in the bag. Ready for more? Let's jump into day 4 and see what's next on the menu. DeepSeek optimizes AI training with smart parallelism and introduces 3 powerful tools to make AI training faster and more efficient. Let's break them down.
DualPipe, a bidirectional pipeline parallelism algorithm for computation communication overlap in V3/R1 training.
DualPipe is all about making AI training smarter and faster by multitasking like a pro. Picture this. You're cooking dinner. Normally, you'd chop all your veggies first, then start cooking, step by step, right? But what if you could chop while the stove's already going? That's the magic of DualPipe. It lets AI process data, like doing the math, and transfer data moving it between GPUs or machines at the same time. No waiting around, it's like having 2 hands working in perfect sync. This combo seriously speeds things up. Instead of one task holding up the other, DualPipe keeps everything flowing, cutting down the time it takes to train those big AI models.
EPLB, an expert parallel load balancer for V3/R1.
So, EPLB stands for Expert Parallel Load Balancer, and it's a genius little tool for mixture of experts, MOV models. You know, those AI setups where different experts handle specific tasks. Here's the catch, sometimes, one expert gets slammed with work while others are just chilling, twiddling their thumbs. That's like a traffic jam in your AI, inefficient and slow. EPLB swoops in like a superhero manager. It balances the workload across all the GPUs, making sure no one's overloaded and no one's slacking. The result? No bottlenecks, no slowdowns, just faster, more efficient AI training. This pairs perfectly with DeepSeek's other tools, like DeepEP and DualPipe, keeping those Hopper GPUs firing on all cylinders. And, of course, it's open source, DeepSeek's sharing the love again.
Analyze computation communication overlap in v3/r1.
Profile data is like a performance coach for AI. It's a tracking tool that helps developers figure out how their AI training is doing and spot any trouble spots. Imagine you're wearing a fitness tracker. It tells you when you're slowing down or where you need to push harder. Profile data does that for AI. It digs into the nitty-gritty, showing exactly where things are lagging or getting stuck. Maybe one part of the model's taking too long, or a GPU's not pulling its weight. It finds those bottlenecks so developers can tweak and speed things up. Bottom line? DeepSeek is making AI training faster and more efficient by using DualPipe, letting AI compute and transfer data at the same time. By using EPLB, balancing workloads so no GPU is overloaded, and with profile data, helping developers find and fix slowdowns. Together, it's like DeepSeek took AI training from a bumpy single-lane road and turned it into a multi-lane highway. Everything flows better, quicker, and with less hassle. All open source, of course. On to day 5.
3FS, thruster for all DeepSeek data access. Fireflyer File System, 3FS, a parallel file system that utilizes the full bandwidth of modern SSDs and RDMA networks.
AI models need to read and write massive amounts of data at lightning speed. DeepSeek's 3FS, Fireflyer file system, is a superhighway for AI data, making it way faster than traditional storage systems. Let's break it down.
6.6 TB/s aggregate read throughput in a 180-node cluster.
Picture this, 180 machines teamed up, reading 6.6 TB per second. That's about 7.26 terabytes in everyday terms. It's like downloading an entire streaming service's worth of shows in a blink. This is the total speed across the cluster, showing off how 3FS flexes modern SSDs and RDMA networks to keep data flying for AI training.
3.66 TB/min throughput on Graysort benchmark in a 25-node cluster.
Graysort is a real-world test for speed. Graysort measures how fast a system can sort massive amounts of data, usually in terabytes. Why does this matter? The faster a system sorts data, the quicker AI models can learn. It's not just theoretical. Graysort shows how well a system actually performs with real-world, massive datasets.
40+ GB/s peak throughput per client node for KV cache lookup.
Here's where it gets personal. Each client node, one of the 500+ machines hitting the system, can pull over 40 GB per second for KV cache lookups. That's key-value caching for AI inference, like a chatbot remembering our convo without rethinking every word. Per node, that's blazing fast, around 43 GB per second.
Disaggregated architecture with strong consistency semantics.
This is the brains of the operation. Disaggregated means storage and compute are split up, so they can scale independently, like keeping the kitchen and dining room separate, but perfectly in sync. Strong consistency ensures every node sees the same fresh data, no mix-ups, like everyone getting the latest menu at once.
Training data pre-processing, dataset loading, checkpoint saving/reloading, embedding. Vector search and KV cache lookups for inference in v3/r1.
This is 3FS showing off its versatility. It's the backbone for DeepSeek's v3 and R1 models, handling everything from prepping data, loading datasets, saving progress, searching vectors, to caching for quick inference. It's like a Swiss Army knife for AI workflows. Alright, let's wrap up this 3FS magic from DeepSeek with a quick, friendly bottom line. The Fireflyer file system, 3FS, is like slapping an ultra-fast, high-speed storage system onto AI, letting it gobble up massive data piles in a snap. It's like swapping out a clunky old hard drive for a supercharged SSD, but scaled up for Ari's wildest dreams. DeepSeek's basically handed the community a turbo boost for big projects, all open source. Thank you for watching. That's a wrap on DeepSeek's Open Source Week. I hope this breakdown made things clear and easy to understand. If you found this useful, don't forget to follow, share this video, and drop a comment. Let me know what you think. Till next time, stay curious.